Okay, let's continue. Rational numbers. So let's begin. Let mn be integers. The solution of n plus m n plus box equals m is box equals m plus minus n. So we can ask, let m n be integers, n not equal to 0. What are the solutions of the equation n times box equals m? So definition: rational numbers. Let m n be integers. We define m by n is the unique point on the line box such that n times box equals m. So this, to make sense of the definition, we need to ask, can we multiply any point on the line with an integer? So m by n, we define it to be the unique point on the line such that n times that point is m. To make sense of the definition, can we multiply any point on the line with an integer? So only then can we define this term n times box. An integer times any point on the line, how do we define that? Right. Once we define that, we'll be done. So we define an integer times a point in this fashion. So consider 0 and some point x. Then so what is twice of x? So we want to define an integer times x, right? So first we'll define 2 times x. 1 times x will be point x itself. So this will be point 2x, 2 times x. Similarly, if we take like this point will be minus 1 times x. And you can even extend like point this point will be minus 2 times x, and so on. So this is a positive point times any integer. This is how we define multiplication of a point by an integer. So another example where the point is to the left of 0. So say this is the point x. Yeah, this length is okay. Point x. Then so 2 times x would be 0, like this and like this. This point will be this point will be 2 times x. So here we are defining 2 times x, here we are defining minus 1 times x, here we are defining minus 2 times x, and so on. This is how we define multiplication by an integer. For a point which is on the right of 0, for a point which is to the left of 0, 2 times x would be like this. Minus 1 times x would be like this. You take the same segment but to the right. This will be point minus 1 times x. So this will be minus 1 times x. This would be point minus 2 times x, minus 2 times x, and so on. So for a point which is to the left of 0, or I'll write, consider a point to the right of 0. And for the second example, consider a point to the left of 0. Then we define 2 times x, minus 1 times x, minus 2 times x, and so on, and other multiples in this fashion. So we can multiply any point on the line with an integer. Now that we have defined multiplication of any point on the line by an integer, now the definition of a natural number m by n is clear. M by n, just to recall, for let m and be integers, sorry, I need to take n not equal to 0. We define m by n to be the unique point on the line such that n times point box on the line such that n times box is m. Okay, so so to make sense of the definition, we needed to understand what an integer times a point on the line means. Then only we can make sense of the definition. So an integer times a point on the line is defined as below. Now the definition of a natural why am I writing a natural number? Rational number. The definition of a rational number m by n is clear. So now an example, 1 by 2 is the unique point box such that 2 times box equals 1. So if you take the line, number line, a 0, and somewhere here you have 1, and is the unique point. So consider this point box. Box is the unique point such that 2 times box is 1. So if you take the point twice, you get 1. Hence, box is the rational number half. Okay. So this is the rational number half. Another example. Minus 1 by 2 is the unique point box such that 2 times box is minus 1. So consider the number line. So somewhere here you can take minus 1, and this point box box is the unique point such that 2 times box is minus 1. Hence, box equals this rational number minus 1 by 2. So this point box is intuitively, and here existence of rational numbers is justified by intuition. Let me write it down. Existence for any integers mn with n not equal to 0, existence of m by n is justified by our intuition on the number line. By our intuition of the number line. There is, for example, in this specific example, minus 1 by 2, minus 1 divided by 2 is defined to be the unique point such that 2 times that point is minus 1, and box is the unique point such that 2 times that box is minus 1. Hence, the point, hence above box is 0.1, or I'll write it again. Hence above box is half. So the marked point is half. This marked point is minus 1 by 2. So another example where we have negative number in the denominator. Example 2 by minus 3. So let me start. What is 1 by 2? So here also, what is minus 1 by 2? By definition, minus 1 by 2 is the unique point box such that 2 times box is minus 1. And on the number line, we see that this point which we draw here, the midpoint of 0 and -1. This point, this is the unique point such that 2 times box is -1. Is the only point such that twice of that is -1. Hence above box is -1/2. So now again we can ask, like, what is 2 by -3? Okay, so 2 by -3 is the unique point box such that -3 times box equals 2. So what we can do is we can consider 0, -1, -2, and then we can consider we can break this segment into 3 parts, 3 equal parts. And now the claim is, you consider this point box. Now intuitively we see box is the unique point such that -3 times box will give you 2. Hence above box equals -2 2 by -3. Okay, this is what 2 by -3 means. Is the unique point which when multiplied by -3 gives 2. By construction we can see that this is the unique point such that when you multiply that by -3, meaning you flip it and flip the direction of the point, and not direction of the point but flip the direction, so to speak, and take it 3 times, you should get 2. So this point is the unique point satisfying this condition. Hence this point is above box is 2 by -3. Okay, I'll color all the should I make it in, yeah. What is 1/2? What is in fact -1/2? What is 2 by -3? So these are examples of the definition. So this is the main definition. We define m by n to be the unique point on the line such that n times that point is m. This is the main definition. So these are specific examples, 2 by -3, and we'll take another example just to clarify our intuition. What is, so where both numerator and denominator are negative integers, -3 by -4. What is -3 by -4? So by definition, -3 by -4 is the unique point box such that -4 times box gives -3. Okay, and let's see, consider the line mark 0 somewhere. We want minus 4 times the point to be give minus 3. Let's mark 0 somewhere to the left. So we want that point. Once we flip that point and take 4 times that segment, you should get minus 3. So the point should intuitively should lie on the right, to the right of 0. And what should its length be? Let's see. Let's mark 1, 2 and 3. Now its length should be such that 4 times its length. If you take the point 4 times, you get, if you take that length 4 times, you should get the length 3. So you break it into let's see, how can we break it into 4 parts? Okay, 1, 2, 3 and 4. Suppose these are equal parts. Then this point box, we see that, how did I write here? Yeah, box is the unique point such that minus 4 times box equals minus 3. Hence above box equals minus 3 by minus 4. Okay, so we've taken some examples to show like what exactly do we mean by minus 1 by 2, 1 by 2, minus 1 by 2, 2 by minus 3, minus 3 by minus 4, so on. So this is what the definition says, and the existence of these points is justified by intuition. They exist for any integers mn with n not equal to 0. The existence of m by n is justified by our intuition of the number line. Right, so that's all for this part. See you in the next part.